We're going to look at tonight very, very quickly, go through iteration. So program flow. A program is a series of instructions, sequence of instructions. Now you can give the computer instructions one at a time and you can have it go through linearly. But that's not going to do very much, do anything all that interesting. So what we need the ability to do is to repeat a set of instructions multiple times, and that's called iteration. And not just one instruction, but a code block, a set of instructions. We want to repeat it multiple times. Now, it's important that there are patterns for doing this. So there are essentially three patterns, basic patterns. There are others, but we're going to go over tonight three patterns of doing iteration. And I'll explain them as we go through one at a time. The one basic pattern of iteration is we have a collection. And if you were in on the previous session or last week or so, then you know that there are four basic types of collections in Python in the standard library. What are those? Lists, tuples, dictionaries, and sets. Okay, so we have a collection, some collection, and a very basic computation that you will want to do is iterate over that collection one member at a time and perform some operation on that member. Then I want to go on to the next member in that collection and perform an operation and keep going one at a time until I reach the end of that collection. All right, so that's pattern number one, where we iterate over a collection. We go into the collection, pull out some member, perform an operation, cast it aside, move on to the next member in the collection, perform an operation. And when I say perform an operation, I might be doing multiple things. I could be issuing multiple commands. But the idea is I'm iterating over a collection one at a time until I've exhausted the collection and so on. Okay, so that's the first pattern. So let's take a look at an example of this. So I've defined a list, so it's a collection. And suppose what I want to do is I want to know the length of each item in that collection. So the items in that collection, I have four elements in the collection: mauve, ochre, damask, catalia. So I have four colors represented as strings. And what I want to know is I want to know the length of each item in the list. So how am I going to do that? Well, what you're going to do is, one way to do it is to define a for loop. And the syntax for a for loop is going to be first, this is actually the variable that comes second. For something in colors, the list or collection that I want to iterate over is defined after the keyword in. So colors is the collection that I want to iterate over. When I pull something out from that collection, I'm going to bind it to a variable, and that's where you give it the name color. Okay, so color, I have the list colors. I'm going to go into the first element in the list. It happens to be mauve. I'm going to retrieve that item, assign it to the variable that I've defined here called color. Then my code block begins. Here I just have one instruction. What am I going to do? I'm going to print the value of color and the length of color. And once I've done that, notice it's indented after the colon sign. It will go to the next item in the collection, ochre, print its value and its length, and then keep going until I've exhausted the collection. So actually just 2 lines of code here, and I get the results. So I could have a very, very long list. I could have thousands of items in my list, and I'm performing an operation on each element of the list. All right, so I have the answer to that. Next example, I'm doing exactly the same thing. The for loop is exactly the same. I've just made the print statement a little bit fancier using formatted printing. Take a look at this. I won't explain this right now because I want to cover quite a bit. But the idea here is I say F for format, the string that I want to print out. Anything between the curly braces is a variable. So whatever is the value of the variable, it gets inserted between the squiggly brackets. And now I have a prettier formatted output. The length of mauve is 5, etc. Okay. Now, here's another example. Suppose we want to retrieve the authors in the list. So first I'm going to define a list here. This one is a nested list. So let's just take a quick look at this. So I've defined a list and called library. The name of it is library. And if I want to look at the first element in the list, it's a list. It has 2 elements, the author and a book that he wrote. If I look at the third element in my list called library, which is the second index, this one has 3 elements. It's also a list. It has 3 elements. The first is always going to be the author, and then I have 2 books by Friedrich Schiller, Wallenstein, and on the aesthetic education of man, and so I can look at elements of that list. Okay, so now suppose what I want to do is I want to go through the list one element of it at a time, and I just want to extract the authors. So I don't want all what they wrote. I just want to know which authors I have in my library. The way I've set up my library is I have a list containing a list of lists, and each element in the list is an author followed by the books that he or she wrote. Okay, so how do I do that? So here again, I'm going to use a for loop. Ignore for the moment the first variable. What follows the in keyword is the collection that I want to iterate over. That's library. So I want to iterate over the collection library. I'm going to go into the library, retrieve the first element, and I'll use a variable to capture that first element. I'm calling it entry here. And the first one will be Stefan Zweig, the list Stefan Zweig and the World of Yesterday. I want the author. I don't want so the author is the first element in entry, and I'm going to assign that to the variable author, and then I'll print it. So here, the code block under the for loop has 2 statements or 2 instructions. The first instruction retrieves the first element from the list called entry, and then the second instruction prints out the value corresponding to author. So let's run that, and now I've pulled in the list of authors. Now let's do something a little bit more intricate. If you're not following everything, that's okay. What I want you to get tonight is this idea of pattern when I iterate over a collection. And iterating over a collection will allow me to go into the collection, operate on one element at a time on the entries. So suppose you wanted to take your list of authors and books and retrieve the list of authors, but I don't want the list of author names. I want their initials. Okay, so how am I going to do that? Okay, so same idea. We'll set up a for loop for entry in library. Library is the collection that I'm iterating over. Entry is going to be the variable name that I'm going to use for an item in that collection. When I retrieve it, I'll take the first item in that list, which is the full name of the author. And I'm going to call that author. Then there's a method. If I have a string object, I can split it, and it splits by default by spaces. So if I have a string, some set of characters, space, another set of characters, it will split the string by the space thing, and then create a new list of all the characters. So I'm creating a new list called names. I know there's a lot going on here, but I just want to, you should, study this on your own time. Conceptually, what I'm trying to do here is illustrate the idea of iterating over a list, performing a set of operations, and it's going to do that one at a time. So then once I have a list that has the author name split, then I'm going to retrieve the first initial and the second initial for the last name, and then print that out. So let's run that, and this comes back with the initials. To see it a little bit better, let me just type here print names. Right, so names is a list. So this split operation, or the split method, takes a string and parses it, so it breaks it up into characters based on spaces. All right. Okay, so here's another quick example. This is actually a much better way of structuring your library. I'm going to call it LIB. Here, instead of using nested lists, what we're doing is setting up a library, a database, if you will. So here we're setting up a dictionary. We're going to use a dictionary. Dictionary is called library, or LIB. We define a dictionary with squiggly brackets. Key is the author name. The value, so a dictionary is a key value pair. The key is Stefan Zweig. The value is a list of the books that I have in my library by Stefan Zweig. Okay, The World of Yesterday. Then I have William Shakespeare. There's a comma, William Shakespeare, another key value pair. Key is William Shakespeare. Value is a list. Now I have imagine I have two works by William Shakespeare, Hamlet and Othello. Friedrich Schiller, two works, etc. Okay, so I have a dictionary set of key value pairs. The key is a string, the name of the author. The value is a list. The list can have one or more entries. All right, so I've defined the dictionary. Now let's iterate over the dictionary, and we're just going to go, what we're iterating over is LIB, the collection, and it will pull a element. Now, a dictionary is a unordered collection, so don't expect that it's going to pull out Stefan Zweig. It may pull out something at random, and it will print entry. Now let's take a look at what it comes back with. First, I have to define my dictionary. So what I get back when I just use LIB, and entry is going to be, it will pull out the key. You're just going to get the keys coming back. But So, suppose you want not just the keys, but you want the values. You want to iterate over the dictionary, but you want to process or operate on the key as well as the values, or the values. How do I do that? Well, you're going to have to modify the for loop so that instead of saying lib, L-I-B, the dictionary, you're going to say lib items. And what that will do is retrieve for you both the key and the value. And here I'm going to assign a variable for the key and a variable for the value or the values. And so now I've modified my for loop. Here's the collection. lib items says I want to retrieve both the key and the value. And then here's the variable that I'm going to use to bind the value that's returned. Then I'll go ahead and print the author and books. And let me just take that out for the second. So now I'm going to print both the key and the values in the dictionary. Now let's suppose I want to perform some operation on this. I only want the first book in that I have by whatever author. So here I'll say 0, indicating the first position, and that should just retrieve only one item from that list of books. All right. Now we're going to do something fancier. Suppose I want to retrieve all the authors in my collection, in my dictionary library, and I want that in the form of a list. I want to store it someplace. And I just don't want to print it out. It could be 1,000 authors, and I want to store it. And so how do I do that? So first I'm going to create a empty list called my authors as a placeholder. Then I'll define a for loop. I'm going to go over the collection lib. By default, it's going to retrieve the key. The key is the author. I'll get the author. When I get the author, I'm going to append author. I'm going to add it to my list. First time when I go through the for loop, there's nothing in my authors. But Stefan, you'll pick something at random. Stefan Zweig is returned. I append it to my empty list. Then it will go through the entire library, retrieve one key at a time, add that, append that to my list of my authors. And at the end, when I'm finished with the for loop, notice the items underneath the for loop are indented. When I'm done with the for loop, my print statement is outside of the indentation, and I'm just going to print the results. And so what is my authors? I've created a new list called my authors. It started off as empty, and then I performed a for loop. I retrieved one key at a time, one item at a time, and then added it, appended it to my authors, and now I have a new list at the end, the list of authors. Okay, so that's pattern 1. I know I'm giving you a lot, but pattern 1 is, in summary, I have a collection. It could be a list, it could be a tuple, it could be a set, it could be a dictionary, and I want to go in one element at a time, perform an operation or a set of operations on that element, and then go on to the next one and the next one, and so on. Okay, so that's pattern 1. Pattern 2, I want to iterate some block of code n number of times, some number of times, and I know in advance how many times I want to iterate over, roughly. Okay, so let's do with a simple example. Suppose I want to square the first 10 numbers. Okay, so here instead of a collection, I'm going to use a construction called range 10. I'm going to iterate 10 times, starting off with 0. 0 is going to get assigned to num. Then I'm going to perform some operation on num for number. In this case, I'm going to raise it to the second power. I'm going to square it. Then it'll go to 1. I'm going to square that, and so on. Okay, so let's just run this. And what I get is I'm squaring. So the for loop runs 10 times, starting with 0, 1, 4, 9, 16. So it just squares values. Now, a variant of this is, suppose I want to start with the number 1, not 0. If I don't say anything here, it's going to start with 0, go up to 10, but not include 10. Here, I'm going to start with 1, go up to 5, but not include 5. And let's take a look at that. All right. And I'll finish this pattern with an example. Suppose I want to go through a set of numbers and I want to find which ones are even numbers. And what's an even number? An even number is something that's divisible by 2. And so we can use the modulus operator. If it's divisible by 2, then modulus 2 is going to equal 0. So here I'm using a comparison. So my for loop says start with 0, or actually start with 1, go up to, but not including 10. See if it's divisible by 2. If it is divisible by 2, print it. So let's run that. So I get 2, 4, 6, 8. Suppose I were to change that to 100. And so I get all the even numbers starting from 1 to 100. And you can do 10,000, million, whatever. And this is the beauty of computers. They can do iteration multiple tens of thousands of times, hundreds of thousands of times. All right. Okay, so that's pattern number 2. Pattern number 3, and we'll finish with this one. It's a while loop, and here we're gonna iterate while some condition holds, while something is true. I'm going to give 2 examples of this. They're not the best examples, but they'll kind of give you the flavor. So suppose we're creating a guessing game. And the guessing game is going to be, I'm going to come up with a number. You don't see it. Here I'm showing it to you, but suppose I've come up with a number 9, and the person's got to guess what number I have. And if you guess the number correctly, I'll say you win. And if you don't guess correctly, we're going to print out you lose. And we're going to keep going until you guess the number. All right. So I'll explain the logic in just a minute, but let's just play the game. Comes back with the input statement, guess an integer between 1 and 10. I'm going to say 5. You lose. It keeps going. Okay, the guessing, it comes back with the input that keeps iterating this until I get it correctly. 7, you lose. So let's keep going. And now let's just say 9. Okay, it says you win. All right, and it stops. Okay, so here we're using a while loop. It's always true. It's always going to be true. So it's going to execute this thing all the time. It's going to keep going. But we need a way to break out of it, and we'll just see how that happens. Next line, this is the input statement. And the input statement is a way in Python to get an input from your user. We can say guess, so it prints out guess an integer between 1 and 10. I'm putting whatever the person types in as a variable called guess. One slightly tricky part of the input statement is whatever you type in as input gets parsed as a string. So even if I type the number 5, Python is going to interpret that as a string. So here what I'm doing is taking the variable guess and converting that to data type integer. And then I'm comparing it. So if the guess, what you guessed, matches the number, if that's true, then we're going to print you win and then break. We're going to finish the loop. If your guess was else, if your guess was incorrect, then print you lose, and we're going to keep going. Okay, and that's what we saw what happened. We're going to finish with this also an inelegant example, but it will give you an idea of the construction of the while loop. Here we're going to go for a specific number of times. This is probably better done with a for loop, but the number is 9. We're going to set a counter at 0, and then we're going to use a while loop. So we're going to go 5 times, and if you don't guess within 5 iterations, then it will stop. And if you happen to get it right, it will also stop as well. So we have two ways in which this thing will stop. You're able to guess the number in 5 chances, or if you don't guess the number in 5 chances, it will stop. Right? So we're going to say while the counter is less than 5, initially I is 0. So we're going to start, guess the number. If you guess correctly, we compare, you win, break, else you lose, but we're going to keep going. If you guess incorrectly, we're going to keep going. The counter increases by 1. The value initially was 0. Now it's I is 1. We start the loop again, give another try for the guess, and keep going until I equals 5, which is, it's not less than 5. Then that should stop if I haven't guessed already. So let's run this. So let's do 2, 3, 4, 6, 9. No. Okay. So I didn't guess correctly at 5 tries, and it stopped. Okay. All right. So I'm going to end there. Recap. 3 primary patterns of iteration. One very important pattern. Pattern number 1 is we have a collection. 4 basic types of collections. More general term in Python, it's called a sequence, some sort of collection. So sequence is more general than a collection. A string is an example of a sequence. Let me set that aside for now. Think about collection. I have a collection or a sequence of objects, and I want to go through each item in the sequence one at a time, perform an operation. A great application of a for loop, and I'm going to iterate over the collection one element at a time, perform an operation, go on to the next one, and etc. Second pattern, I know beforehand I need to execute a block of code X number of times, N number of times, and typically the way you're going to do that is use what's called range. So you can range from some value to another value and then perform a set of operations within that. And then the third pattern is you're going to execute a block of code while some condition is true. And then if it's not true, if it becomes false, then you're going to step out of that loop.